as follows. So this is rule 5 then. Reflection in the x-axis. So we know this is a reflection in the x-axis, means h of x is the graph that we need to graph. But if h of x is given in terms of f of x, this is the basic one. This is the basic function, correct? So if it's given in terms of negative of f of x, then this is a reflection through what? X-axis. In order to graph h of x, you take f of x and take the reflection through f. Reflection through what? X-axis. So rule number 6, rule number 6, reflection in the y-axis is as follows. This is the rule for reflection in the y-axis. h of x need to be given as f of negative x. Instead of f of positive x, we need to use negative x for the rules. Then it's a reflection through y-axis.
So is the first one only x then?
Yeah, this is a reflection through y-axis. This rule is a reflection through x-axis. Okay, so we'll do a couple of examples here for these two rules. You guys will do this a lot. So example number 1. So which one? So let's say we need to graph, I'm going to use the easiest one that we've been using. Graph f of x. We want to graph h of x is equal to negative absolute value of x, this one. What do you guys think of this one? How do you need to graph? Now this is the graph that we need to do, okay?
Graph the absolute value.
First we need, all these graphs, we are going to use only the transformation, okay? I have mentioned this before, we only use the transformation. So use transformation to graph this function, but we already know without the absolute negative sign here, right? How to graph the absolute value of x. So when you do the transformation, we need to show both graphs, you guys know that. So the first one is, everybody know, 2, 2, 3, 3. So this is the graph.
This is rule number 5, right?
Yeah, rule number 5. I'm going to give an example number 1 for rule number 5, right? So this is you guys know these coordinates, right?
Yeah.
Now if this is a reflection, this is the x-axis. Reflection through x-axis means x-axis is going to work as a mirror, right? This is the mirror. Reflection through x-axis means x-axis is the mirror. Reflection through y-axis means y-axis is the mirror. Okay? So that means the mirror image of this point is here. You see this? Just take the mirror image.
-1, -1.
Yeah, -1, negative mirror image of this point is here. +1, -1, mirror image. Just think of the mirror image, okay? That's it. You take each point, take the mirror image, and you see whether when you draw the mirror image, it needs to look exactly like the mirror image. I'm sorry? So I'm going to graph this, okay? So this is the h of x graph. This is, okay, I'm sorry, I need to graph this more like dotted line, remember? So we need the basic one, always use the dotted because that's not what we are looking for. That's our tool. We are using that to graph this. That's it. So both graphs need to be shown on the same coordinate plane, right? And this is h of x is equal to what here? Negative x absolute value of x. And this one is, you can label both graphs, that's fine. This is f of x, y is equal to, or you can say y is equal to absolute value of x. F of x is the y in there, the basic one. Very easy, right? So, all functions like basic ones, if you have example, let me do. Can you give me another? You guys give me another example for reflection through x-axis. Book has about 3 examples for you. You can come up with any problem. What do you like to work with?
H of x equals negative parentheses x plus 2 squared.
Oh, okay. H of x is equal negative parentheses
X plus 2
x plus 2
squared.
square. Good example. But this we know, before reflection what we have? Horizontal shift to the right or left. So here we are doing an example, very good, where we have to do the horizontal shift first and then do the reflection. Okay, so let's work on this real fast. So, pens are kind of dying. Okay, so let's do. First we need to get the basic one, right? So what's the basic one?
It's like a parabola.
Which is what? X squared. By looking at this, we know the basic one is x squared, right? So we know how to graph x squared. 3 and 9. So here. So that's the basic one. That's if this is x squared. But now we need to move this, how many? 2 to the left, 2 to the left. So pick up your points here. Consider your points. This goes 2 to the left, so this is here. This goes 2 to the left, so this one is here. This goes 2 to the left. Right? This goes 2 to the left. This is 2 and 4. So it's going to be 2 and 4 and 2. 4 and 4, correct? 4 and 4. If you move these two, 4 and 4. And this one is 2 to the left here. So this coordinate is 4. Is this the real one that we need to graph?
No.
No. Now this is still, this is part of the transformation. You can do this and do this graph also. Now look at this graph and we need to do the
Reflection.
reflection through x-axis. Whenever you say reflection, you need to say what is the mirror, x-axis or y-axis? Which one is the mirror? If you say just reflection, then there's ambiguity there. You don't know which one. Because there are two reflections here, you see that? It could be reflection through x-axis or reflection through y-axis. So, this one reflect. So this point reflection stays the same point, correct? This one reflect, you go here. This one reflect, go here. You guys should be able to read the exact coordinates. This one, reflection, this is 4, correct?
Yes.
4 going to be -4. This is then 0, -4. And this one, 4, same x coordinate. Right? So here's the last graph, which is going to be a solid graph. This is the one, h of x, that you need to graph is equal to negative x plus 2 whole thing squared. Now you can see in this case I did 3 graphs that you can do, or you can go from here to here. You move to here, you can do this. Move to, reflection stays there. This one, move to 1, 2, and then the reflection down 1. Right? You can get the reflection after you move 2 to the right and then get the reflection of that point. You don't have to graph this one to get the reflection. But if you do this, this is good, you see the reflection step at a time. Does that make sense? So on the test, the hardest you get is something like this. I can do the same. Now how many problems I can create? We know we have 6 basic functions that we are familiar with. There are more basic functions, but I'm only going to test you with those 6. Okay? Everybody very familiar with the 6? You know exactly how to graph those, and then use those. Then whatever we get here is something that we are going to use one of those basic. Okay? And we can cover this. Any question? All right, so let's do, oops, sorry. Okay guys, so we did 2 graphs of reflection through x-axis. I'm going to erase this, guys. Everybody done with this too? I'm going to erase this, okay? So these are 2 examples from rule number 5. Anybody else who like to give me another example for rule number 5? I'm not going to do it if you guys can do this, but can you give me another example where we can use the reflection through x-axis? And maybe horizontal transformation, vertical put 2 transformations, example like this. Okay, go ahead.
Negative.
H of x, we are going to graph h of x. So this is example number 3.
Negative x plus 2. Negative x minus 3. Negative x squared minus 3.
x minus 3,
No, negative x squared minus 3.
x squared minus 3, like this. You can see this? So what kind of, before we reflection, what do we need to do first?
Draw the basic function.
Huh?
First you draw the basic function, just
Yeah, we work with the basic function which is
x squared.
X squared.
x squared. What do you need to do to the x squared?
Shift.
Shift what? Shift.
Horizontal to the right.
Horizontal shift.
To the right. I mean, yeah.
Down.
Down. Horizontal shift down.
So it's vertical.
Excuse me, thank you. Yes, vertical shift down, right? You do vertical shift down and then you do the reflection through x-axis. Okay? Okay, so let me go through the other examples and I'll go through this real fast, okay? Okay, so let me example number 1, 2, 3 for this. We are going to do one with vertical. Rule number 6. Okay. So I'm going to give this example. F of x graph h of x equal to, how about square root of negative, oh I can do this, yeah, square root of negative x. Okay, square root of negative x. Now, you guys know, if we have f of x is equal to square root of x function, how to graph this, right? That's the basic one.
Yes.
So let's graph that first. So is that the one we need to work with here? Right? Okay, so this square root of x, and we know how to graph that. 0, 0, 1, 1, 4n,
2,
2, 9n,
3,
9n, 3. We know the domain, range, of all these functions, right? So now the graph of this is this is the dotted graph. Are we good with this? So this is 1, 4, 9. I only picked the points that I need, okay? But they have to be proportional, okay? 1 here, 4 here, 9 can't be here. You see what I mean? Make sure that you work with, when you're doing homework, I think it's really good if you can do the work with graph paper, okay? Okay, so now, we want to get the reflection through y-axis, this is. So this is the y-axis. So we don't have to worry with the ordered pair how this is going to work. We know this rule is basically reflection through what? Y-axis. So what you need to do, this the y-axis is the mirror. What's the reflection of this point? Here?
Of 1 negative.
What's the reflection of this point? Negative 4n,
2.
2. All you have to do is the rule. Use the rule. The rule will cover all the true statements. Okay? 3, 9 and 3. So we are going to graph these. Oh man. So this graph is h of x is equal to okay. So we did one with the reflection of oh, that's the same one that the book has. Okay, so now I'm going to do something else here, guys. Okay, I want you guys to actually work with the classwork problems now, couple problems, okay, because I told you I'm going to give you classwork problems, right? So take about 10 minutes, and I just want you to get a feel to how to do using these 6 rules, right? Then I'm going to do the other 2 rules today. Actually, we have 4 more rules today, okay? So let's do a couple of, about 3 classwork problems, take about 10 minutes. And so I'm going to write these problems. So we haven't done a classwork assignment for a long time, right? So let's do classwork. I think this is classwork number 4 or 5. I'll figure that out, okay? We haven't done a classwork for about 3 weeks, I think. Alright, so we do a classwork assignment today because you guys need to, I have to make sure that you are very good with this. We took a lot of time and I went all these rules, I took a lot of time to cover this carefully. Okay, so still you need to do it on your own, by yourself. Okay? Okay, so I want you to do problem number so some of this okay, page 226. So I gave you guys 3 problems from here. So you can also do these problems now. Number 28. Number 28. And you can also do, there's not many here, number 41. You guys have the book, right? Number 41. And then number 49, I want you to do this way. Number 49, graph g of x is equal to x minus 9 square root, and then with the negative here. Okay? Now number 28, okay, work with these three. So let me write number 28 here. What is number 28? G of x is equal to negative x cubed minus 1. G of x is equal to, so just do these three. This is only with the x, I'll do another 3 for the y. Negative x minus 2. So this is easy one. Now guys, when you do this, the vertical transformation, the vertical shift, you guys have vertical shift here, correct? Vertical shift you do at the end, okay? You do the exponent first or the parentheses first, and then you do the reflection, okay? After that you do the vertical shift. Vertical shift you're supposed to do all the way at the end. It's like addition, subtraction you do at the end, correct? With the Order of operation, do we do addition subtraction at the end? Order of operation class? It's the same thing here. If you have addition subtraction here with a number, see unit, we do the vertical shift. So whenever we do the vertical shift, after you do the reflection, do the vertical shift. Are we following? It's just like doing the addition subtraction on order of operation problem. We add the addition, do the addition subtraction after we do all the other operations. Okay?
The 149 is this program or your program?
Oh, I want you to do this one. 49, I want you to do this one. So these are 3 problems that we are doing. You need to show me all the graphs, the 3 graphs or the 2 graphs, at least 2 graphs. Yeah. Sorry. Excuse me. Thank you. Oh my goodness. So we are still on 2.5. Almost done. So for an example, if I had this, plus, let's say plus 2, then this is also a dotted,
So vertical.
yeah, then I'm going to move these 2 units up. You see that? You do the vertical shift or the horizontal shift after you do the reflection. Okay? So if I move this up, so take every point, move up 2. So this is here, this point, move up 2. So that's here, this point, move up 2. So that's here. So the graph goes from here like this. So this is the final graph of h of x is equal to absolute value of, square root of negative x plus 2. Okay? Did I do an example? I didn't do an example with going up down, correct? I think we wrote one. We wrote one, but I didn't do that. So you can take this as example number 4. You can write this up, example number 4. Okay, so I'm going to write the other 2 rules. Just we need to rule number 7 and 8. I think the book is calling compression as, I think book is calling as shrink. Shrink, yeah. Vertical shrink. Vertical shrink. We discussed this last class meeting, so let me write this rule here. So this is rule number 6. Are we good class with the classwork?
Oh, you mean the actual?
Yeah, the actual.
Yeah, I just like.
Oh, it's not bad. Takes forever. Yeah, exactly.
I should go.
Oh, yeah. It's a complicated graphical function.
So this one, which is 2, 0, 1, 2, which is 1. It always starts at the 0.
For the absolute values, yeah. Minus
So it's like the negative 2.
So you just need to do 2. Still 2. And then
That makes sense, thank you.
So just make it a positive 2.
exactly.
Oh, okay.
Yeah.
Then first I'm like, I need to solve it, so that's why I decided to take.
You guys done?
This one is negative 9. So it's 2, 3.
Yeah, but they're, it looks like it's, but that, never. I didn't know that. It's just how it's the symmetry of it. Yeah. Yeah, because the bottom of it. Just, I think that's just how that.
Yeah, I kind of like just got the big
Okay, so the basic is equinox
This is good.
Okay. Hold on to your classwork. Are you guys done, right? No. Okay. Hold on to it. I'm going to give you another 2 problems after I'm done with this. I'm done with this.
Yeah, because it's next.
So, guys, please write this down. The other 2 rules we are going to discuss today is vertically we are going to stretch the graph, or vertically we are going to compress the graph. Compress means shrinking, right? Okay? So the rule, when we are going to vertically stretch, when we are going to vertically compress, these are the 2 rules. 7 is vertical stretch. That means we are pulling the graph up, or pulling the graph, right? We are pulling the graph. This one we are pulling the graph. We are pressing the graph. Compress is pressing the graph down, right? Okay, so let's see how we are going to work with this. Example number 1 for this. F of x on, we are asked to graph h of x is equal to 3. I'm just going to work with the easy one that you are familiar with. This first, okay? What is your A here? So we are supposed to graph this. We have not graphed something like this before. So do you guys see this is with this rule? A is the number in front, A is in terms of multiplication. It's not addition, subtraction, it is multiplication. So when a is in terms of multiplication, and then we have f of x, this is the parent function, the basic function, one of the basic. So this whole thing become the y value, correct? So whatever the x value need to be, what we get from here, whatever the x coordinate, then the whole y coordinate need to be multiplied by 3. So x coordinate stays the same, but the y coordinate being multiplied by 3. So that's why we get vertically, we have to pull up vertically. Okay? So we are going to do this. So I'm not explaining this, you guys know exactly what I'm doing here. So I have these 3 points here and okay, 5 points. Each point I need to take the y coordinate, multiply by 3. What happened here? 0 multiplied by 3, it becomes 0. What's the y coordinate here? X coordinate stays the same. 1 here, 1 here. 1 multiplied by 3, 3. So y coordinate, x coordinate 1 times 3 is 3. So it's 1, 2, 3. So this is the other. This is 1, this is the other one. This one, what's the x coordinate? 2, y coordinate is 4. We take 4 and multiply by 3. What is happened? 12. Only y coordinate. We are going to vertically stretch y coordinate. Whatever the y coordinate you multiply by that factor a. Okay? So what happened here?
Stretch.
4, 2 stays the same, 4 multiplied by 3 is 12, so this is all the way up, right? We do the same thing here. One multiplied by 3 is 3, and then up. So the new graph is like this. So when it's going all the way up, okay? Up to 12 then, right? So you guys can see the graph become narrow. Okay? And it's stretching. When you stretch up, the graph become narrow. Vertically stretching. Okay? Now the same thing if we have, let's say I'm going to do another example here, h of x is equal to negative 3x squared. Okay? Now you can do this either way. You can do the stretch this like this, and then you can, what do you need to do to this after this? What's this negative sign?
Times it by -3.
Yeah, but what is this? Let's say we didn't have the negative sign, we did this graph, right? Now with the negative sign in front of the graph, what do? Reflect, right? So we can do this and then reflect this. So this graph is the h of x is equal to negative 3x squared. Okay? Now, we can do this way, or when we do this, we can also do this. The reflection you can consider it like this also through the x-axis, reflection through x-axis. So we graph the original x squared, and then we are going to take each point, multiply by this time negative 3. So this is 1, 1, multiply the y coordinate. Vertical stretch means we only look at the y coordinate. Okay? If the A or C is outside the constant, outside the graph, the basic function, then we multiply only the y coordinate. You have to follow the rule. You have to understand the rule, the wording, the written. Okay? Different books write this little differently. It's the same thing if you read carefully. Okay? You follow. So what do we have here? 1 multiplied by negative 3 become what? Negative 3. So x coordinate is the same, now y coordinate is negative 3. This one, what's the coordinate? 2 and 4. 4 multiplied by negative 3 become negative 12. So x coordinate is the same, y coordinate is negative 12. So this is 2 and negative 12, and this side is negative 2 and negative 12. So the graph goes like what? And then 0 and 0 stays the same, right? So we have from here to here, going this way, here to here, going this way. This is the final graph. So I did graph this graph without using the reflection. Do you guys follow this? You can do that too. You don't have to use the in other words, what we did with x negative x squared this, and I did this for negative x squared, I should have said x squared and multiplied by negative 1, the y coordinate. Then I get this. Okay? Because x squared can be, negative x squared can be written as what? Negative 1 times x squared, correct? So that means this is my A now, negative 1. Right, Paul? Okay, so whatever the graph become stretch up. Okay? Stretching. So if it's a negative number, it's going to, you're stretching, it's a reflection, so you're stretching down. Okay? Now A has to be greater than 1 here for this case, to have the stretching. A has to be greater than 1 number. They are calling here absolute value of A. That means A has to be a positive number to stretch up. Okay, that's what they're saying. If A is a negative number, then you are going to reflect and stretch down. Okay, That's what the absolute value means. Okay. By a factor of a unit. So everybody understand the rule here? Okay, I'm going to take, oh my goodness, few more minutes to, I don't think I have time to cover the other two rules, but let me do this one.
We're talking about something.
If A is less than 1, A can be also less than 1. What are the values less than 1?
0.
So A is a value, it could be positive or negative, we are looking at absolute value. So number less than 1 is between 0 and 1. It's a fraction between 0 and 1. Okay? So when it's a fraction between 0 and 1, we are going to use rule number 8. Example number 2 here, f of x is equal to, let me work with absolute value of x, and I'm going to say 1/2. Graph this, see what's going to happen to this. Or example number 3, h of x is equal to negative 1/2 absolute value of x. Let's work with the basic ones because these are heavy rules. So you have to know how to work with the simple ones first so you can work with the little more challenging ones out, okay? Because most of you guys are doing this for the first time, right? But you understand. Okay, so let's do this. So the thing is, whenever you see this, if you're comfortable with the rule, you know exactly which rule. So you have to be familiar with the rule. Okay? Now book is not giving this as rule number 1, 2, 3, 4, 5, 6. No, I made it like that so that you know there are this many rules. Each one has its own. Okay? So this one is, we know A is, there's a multiplication here, and the A, the number, there's a number here, numerical, constant, the number is in between 0 and 1. So this has to be vertically shrink. We are shrinking, compressing. So if you hear the word shrink, compress, it's the same thing. So let's graph this. Wow. 2, 2, 3, 3. You guys know what I'm doing, right? Okay. See, now we are repeating so many times this. So many rules we are repeating so many times. So, but this rule says multiply the y coordinate by what?
What was that, 2, 2, 2?
Now look at the y coordinate only because it's vertical, means we only consider the y coordinate. When we do rule number, that's the last two rules you're going to do. Rule number, we did 8, 9 and 10. We are going to do the x coordinate, stretching and shrinking, pulling, okay? Here the y coordinate. So what happened here? Y coordinate multiplied by half. What happened? X is the same, y multiplied by half, 1 multiplied by half is half here. X is the same, 2 multiplied by half is 1. 2 multiplied by half is 1. X is the same, 3 multiplied by half is 1.5. You see that? So now we get this. It's the same here. Y one and a half is here, so do you see the picture here? If you go here, this is a wire, you compress, then the wire is going to open. So the wire will be wider. Okay? So when the factor that you are multiplying is a fraction, proper fraction, this scenario happen. That's all. Okay? Now if this is a negative fraction here, what will happen? Yeah, we take this and we flip. Now we could have done that simultaneously also, you guys know that, right? What do you have to do then? If I have to do the negative one simultaneously together, we can do this as a, what? We don't even have to do this. We take the y and multiply by negative half. So keep the same x, y get multiplied by negative half. This, even though it's written as two rules, this is actually one rule. You always multiply by what? By a, whatever that a. Okay? You keep the same x coordinate, multiply by a. A can be greater than 1 or a can be a value in between 0 and 1. So it doesn't matter what a is, all you have to do is multiply by a. So some cases it become a narrow, a straight, some cases it become wider. So it's the same rule, they're breaking up into two rules so that you see when is what happening, which one is happening. Okay? And same rule, the negative one, also part of what? Part of taking the y coordinate and multiply by a. Okay? So you get the reflection through x-axis. So I'm definitely going to have lots of examples, reflection through x-axis, vertical stretch, vertical compression. We still need to cover horizontal stretch and horizontal compression, right? That's horizontally, we pull this way and you stretch this way, shrink this way.
Yes.
That's, we need to put this A inside the parentheses. Okay? So we are going to talk about it in the next class meeting. Okay guys, I have a couple things to say now, I have like 3 more. Okay, so why don't you guys do this problem for me for classwork now? Work on this, number 4. This is add to the classwork. 2 minutes, take, how about, okay, I'm just going to give you the easy one. X squared okay, did I do this one? I did this one last time, right? Yeah, I did this one. So let's take this one to be square root of x. Easy. Okay? So maybe I'll put a negative sign. That one, easy one. So classwork, how many problems I have? 4. Okay. So everybody understood the vertical stretch and horizontal. Vertical shrink or call it compression.
Is that -3 or?
Yeah, -3. So guys, are you going to bring the practice test for me next class meeting?
Yeah.